Okay, how I was showing you this pattern with 7 times 10 equals 70, and then adding it down. 7 plus 70, 21 plus 70. That's because they're multiples of 7, and I switched them up to the different, because primes in 1, 3, or 7. 1, 7, 1, 9, 3. But this is where twin prime should be like 7, 9, but it does have 1, 3 there because 1, 3, and 7, 9 share the same spots. There's where a 7, 9 should be, 7, 9 should be, 7, 9 should be. Same thing for this. And here it is with these. That one was a mistake, but as you notice, it's still following the pattern of 1, 2, 3, 1, 2, 3, 1, 2, 3. Same thing for this 1, 2 are not where the 7's supposed to be, but that one is. And then it alternates to where this one has 2, this one has 1, this one has like 2 back to back, and this one only has 1 every third because that spot is alternating with that. And then same thing for these two are alternating with this line. And this one I completed so it's easier to see. These two are where the prime should be, or prime should be. There's that, and it's kind of alternating back and forth. And then it does the same against these lines. Same thing here. So there will be 2 of these lines where 2 spots should be. But so I went ahead and did this. Before I go on. Okay, 77, 147, and that's what I was starting on this line. And I highlighted this line because this line will be where all the twins should be. So I just went ahead and stopped writing these ones. And the 3P means three primes. G8 means a gap of 8, so that means 491 and 499 was a prime. 701, 709 was a prime. G6 is 1123, 1129. No primes were there. G6, 9, that means 2179 was a prime. And then the square dots is where primes were at, and the only primes that twin primes could be is 2591 and 2593. And that's just a mistake. The 3 is the only prime there. Twin prime, twin prime, twin prime. And I'm going to go do it on this, just I haven't gotten to it because I wanted to see what would happen if I went to a bigger number like 101 and did the same, and how that is 7 times 10 going down this line. The reason for 210 is 3 times 70. So it'd be 30 times 7, 30 times 11, 30 times 13, 30 times 17, and then 30 times 101. But the X's are where there are no primes. And depending on, there's 3 primes, but twin prime, 2 primes with a gap of 4, which would be 3 and 7, and twin prime, gap of 4. And then I went to an even bigger number, and this is where twin prime, I'm trying to find twin prime spots, but 7, 9, G4, no prime, but it's still a high chance of finding a prime. And I was going to start with a bigger number, but I think I picked the wrong number. The reason I picked that is because there's an online site that has prime numbers recorded up to 1 trillion. So I went ahead, because this is a 25-page thing, I went ahead and went with 30. I need to pick a number around 33 billion, 100,000 million. Yep, 33 billion. That way I can get about 20 increments in, 20, 25 increments in before there's no more data. But that's just twin primes 1, 3, and 7, 9. But then I went and did this, which is same thing, 30 times 3 twin primes, because of 29, 31, 9, 1. And I start going down. The 1, the 9, the -1, +1, no prime. Just to see if there was what might pop out. And then I went into full detail with 60s, and then I separated it into 3 lines, just like how I did how I do this right here, but just focused on that on the 60s. And that's why I got 1800, because 3 times 60, or 30 times 60 is 1800, and then times that by 2, that way, because it goes down 54, because that's 1800 plus 1800 plus 1800 is 54, and then 54, 54, 54, 54 going down. But there's twin prime there, 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 and then so far there's no twin prime there. And my hypothesis is just like the 2/3 patterns, is that this line won't have twin primes, but these 2 lines will have twin primes. And if you check the X's to the primes found, there's less X's but in these 2 lines alone, it's a 50-50 shot that you'll find a prime, roughly, because there's 12 primes in here, and this goes to 26. And I think this one had 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 in here. And then this line that won't have twin primes had the least amount of X's. 1, 2, 3, 4, 5, 6. And but as I'm working on this, I'm seeing that I can jump bigger numbers and find primes, because shouldn't be finding primes so easily jumping number lines this huge, because that's 60 all the way to 138,000. And so far I'm finding primes more than 50% of the time. But I mean, as the number gets bigger and bigger, it'll be less frequent. That's for sure. I'm not saying that you'll always find a prime or you'll always find a twin prime, but this makes jumping through the number scales easier. And that's the point I was trying to make with this video, is that it'll let us look at the data with primes and twin primes more fluidly. And what I'm thinking next is doing this 3 grouping with these lines and seeing how, cause 3 twin prime, no prime, 6 no prime, 9 1, 12 no prime, 15 1, 18 9, 21 no prime. I'm wondering how, if that gets shifted into a 3-column row, how this will line up, because prime should continuously show up in this, and I'm wondering if one of the 3 lines will have no primes, just like how I just jumped so many numbers and was checking them just to see if there was primes next to them like they should be or shouldn't be, or should be, and just finding primes that, like, this wasn't like months worth of work. I probably did it. I just started this sheet like 2 days ago, and the only reason it took me so long to make the video is procrastination. And it took me a day or two just to sit there. Well, not a day. I finished these 2 lines yesterday, and then finished this one today, and just went through and checked them against the list of primes just to see where they were at and what was happening.